Today I'll be presenting the tutorial series from the GeoPM software package, and in particular we'll be going over tutorial 5 in that series. In tutorial 5 we'll be talking about the GeoPM's application-facing progress interfaces and how they impact the trace output. Okay, so here in the tutorials directory we have built the tutorials, and I'm just going to set tutorial 5 running, and we'll do that by setting MPI exec as follows, which is appropriate for 4 application ranks and 15 CPUs per application rank. We're then running 1 controller rank on each node, and that is specifying 2 nodes. So we'll launch that in this way. So we specify OMP num threads to 15 using the MPI exec we just defined, specifying 10 total MPI ranks and launching this tutorial 5 script. And if we look at that script, it's here. It looks very similar to the other scripts that we've been running. The main difference that there is no policy specified, as there was in the last 2 tutorials, because we're not doing control here, we're just showing profiling output. And we're having the output files reflect the name of the tutorial, tutorial 5. Okay. So if we look then at tutorial5.c, we'll see that this main is similar to the others that we've looked at before. The main difference being that we do not specify the region and we do not specify region entry and exit. Instead, we're just calling this function called tutorial stream profiled, and this has those calls built into it. We have an outer sync call and a barrier associated with that synchronization call, and then we loop around. Okay, so that outer sync call is defined if we look in tutorial region.c. And if we look the source file, you'll see that there are 2 subroutines here, stream profiled OMP and stream profiled serial. We'll go over those in just a moment because they're called by the main routine here, tutorial stream. And here we define a region within the function call. GeoPMProf region is called here to get the stream region ID. We set up the arrays for doing the stream call. And then we call GeoPMProf enter on that region ID that was just created. And after we call through to the subroutine, we call GeoPMProf exit. You then see that it swaps on whether the application is compiled with or without OpenMP support on to call the OpenMP version or the serial version of the core of the computation. If we look at the serial version here, it's a little more straightforward to look at without the pragmas. And in here, we'll see that we've broken the stream operation into a sequence of blocks of streaming. And each of those blocks is defined to be 256 elements long. After we complete one of those blocks, we call into the GeoPMProf progress API. And here we're specifying the region ID that was passed into this function and the index of our for loop times this normalization factor, which is defined to be 1 over the number of blocks. So this I times norm gives us a normalized 0 to 1 fractional progress. At the end, there's a section where we finish up the remaining elements that were not within a single block, a single complete block. Okay, and then similarly, we have the stream profiled OMP version. This has these pragmas where we define the number of threads that OpenMP is providing in the runtime. Again, we call this time, we call tprof create here, and this creates this thread profile object tprof by specifying the number of threads that we're working with, the total number of operations that we'll be executing. This tells the block size, which in this case we have not used a OpenMP for loop with a chunk size defined. That is the chunk size in the specification for OpenMP. And then the tprof is the object that we get out, which is then passed to this GeoPM tprof increment after each of the blocks has been completed. And here we're specifying the tprof object, the region ID, and our thread index. Okay, and then if we look at the output from this run, which is just completed over here, we can look at the 3 columns of the trace that are of interest here. Column 1 is going to give the region ID. Column 2 is going to give the number of seconds since the application began. And column 10 gives this progress for the domain of control 0, which we just have one domain of control here. So we see that here, region ID, seconds, progress, those are the labels for the columns. This is the outer synchronization region ID, which is called 1 second into this application, where we actually begin to do the profiling. We see we're not within a region for this beginning few seconds, and that at second 3.5, we enter into the stream region, and we'll see that the progress starts at 0 when we enter that region, and it slowly increases until it hits 1, and this is when we exit the region. There's then some unmarked code. We hit a outer sync, which we exit and then enter. And then soon we should enter again into a stream region. Here we are again in the stream region, and we can see that progress is again ratcheting up to reach the completion point. We see similar results on Mr. Fusion 1's output. It's the other node in the system. So you can see that here. And that gives us all the information we can get out of the progress interface. It should be noted that the existing decision algorithms at the leaf are not making use of this progress. There may be plugins to do decision algorithms at the leaf in the future, which will make use of the progress within a region. At the leaf level, this region information is important and the progress can be used. However, at the tree levels of the hierarchy, the progress information is not really relevant and does not get used by the intermediate tree decider algorithms. Okay, that concludes tutorial 5, and join us next time for tutorial 6, where we will talk about the basic model application that we will use for our integration tests. And this ties a lot of the concepts that we've discussed so far in this tutorial together and to a sort of unified and configurable application that we can profile and control. Okay, thanks for joining.